Welcome to Automated Visual Software Analytics. This part is about the visualization pipeline. We will outline objectives of visualization, we will introduce the visualization pipeline model, and we will briefly show a reference model for visualization. The objectives of visualization are manifold. The objectives include, for example, exploration of large data sets. Also, the analysis of structure, patterns and relations of data sets is among the objectives of visualization. More generally, understanding of concepts and processes and gaining insights and comprehension corresponds to the main objectives of visualization. Visualization serves also as a communication medium and collaboration tool. The term visualization is defined by to make something visible to the human mind. Visualization takes advantage of and uses the human visual capabilities. Now, to outline the visualization pipeline, let's have a look at an example. Below you see part of a data set. It's about parts of a complex system and three different dimensions, different attributes, for example, costs, lifetime, and failure risk. The visualization pipeline now is a generalized model of how we transform data into something that can be perceived by humans. In the first step, we process and filter data. In this example, for example, we replaced some obviously wrong entries according to rules or according to our experience. For example, this number was multiplied and the percentage was expressed in a different scale and range, in a numeric range. In general, processing and filtering includes tasks such as data completioning, data reduction, data normalization, general data filtering, and threshold operations. This is the first stage in the visualization pipeline. We read data and we clean, process, and filter that data. It's called the pre-processed data, the result. Then, the next step is a so-called mapping stage. Mapping means we have to transform data into something that can be rendered later on. Mapping in our example, in our short example, means, for example, to map entries to visual primitives and corresponding visual attributes. For example, we decided here in this example to map costs onto the width of a diagram, lifetime onto the height that we assign to a box, and failure risk is mapped onto a color scale. Visual variables in general include form, shape, color, texture, position, size, and orientation. Once we have mapped pre-processed data, we end up with mapped data. Mapped data typically has a representation that follows types and structures and primitives given by computer graphics. Once the map data is available, we can do the final step, the final stage. It's the rendering stage. Rendering refers to mapping the map data to graphics, to something that can be seen, that can be visualized, that can be interactively manipulated. For example, we can use a rendering engine for 2D or 3D graphics. Common forms include diagrams, plots, and charts. So what you see here is the whole visualization pipeline, starting with data, processing the data, mapping the data onto visual variables and graphics primitives, and rendering the mapped data, resulting in visual artifacts, in visual representations, the frame buffer images, or any other interactive computer graphics. In our example, we can see the different entries in our data set having different width, different height, and different color according to the visual variables that express the underlying data attributes assigned to each entry. So this gives an example of how generally visualization works. We have to define the three different stages, whereas the last stage typically is defined by technical frameworks, computer graphics systems, while the first two are in the scope of the concrete domain. For example, in software analytics, we ask how can we process data taken from software repositories, and the mapping stage includes the key question, how can we map software related data to something that can be understood by users. The reference model for visualization goes further. The reference model considers the whole cycle, how we as users can take advantage of visualization. It includes as a basic element the visualization pipeline, producing images. These images are consumed, perceived, and recognized by users. And due to exploration, we generate knowledge, insights in our mind. And based on this information acquisition process, we may change the specification, we may change the pre-processing or the mapping or even rendering parameters, such that we can better explore and better understand the visualized data made visible by processing the data through the visualization pipeline. The visualization pipeline is part of the visualization process that consists of perceiving images by the human user, obtaining insights by exploration and analysis, adjusting data processing, data mapping and rendering, and of course we have this feedback loop based on the interactive image generation. The user reacts and the user redefines different parameters of the visualization pipelines at the various stages. To summarize this part, visualization is a powerful method to provide users access to and to facilitate understanding and gaining insights into data. Visualization plays a key role if data becomes massive in terms of size, number of entities, number of structure, number of relations, and or if data is complex in terms of dependencies, hierarchies. Visual analytics applies manifold methods, techniques, and tools of visualization to handle and to cope with massive data and big data sets. In software analytics, we use visualization to provide interactive access to software-related data. The key challenge is to find appropriate mappings within the visualization pipeline, because data about software processes, and software evolution has no natural look, no natural appearance, no geometry, no gestalt. For that reason, visualization is a key defining and essential element of all software analytics approaches. Software analytics uses visualization in order to provide users access to complex information about software-related systems and processes. Yes, this concludes this part. Some terminology. We have introduced the term visualization. It's defined by the process of filtering, mapping, and rendering data, the three stages, such that it can be perceived, understood, and interpreted by the visual system of the user, aiming at giving comprehension and insight into the underlying data. Another key term is visual variable or visual variables. A visual variable is a parameter to which data properties or values can be mapped. In visual mappings, visual variables include typically the shape, form, or geometry, the position of a shape within a given reference frame, size, orientation, color, texture, and any further attributes such as animation properties. As further reading, we recommend the book on Information Visualization Perception for Design from Colin Ware. It's a general self-contained introduction to the whole field of visualization. And there's another one I can recommend. It's Visual Explanations, Images and Quantities, Evidence and Narrative from Edward Tufte. Some final remarks. Visualization is not about making something visible to the eyes. It's about making something visible to the mind. So there's a small but important difference between both statements. Visualization is considered to be a key method and technique to cope with big data. That is, it offers ways to access, grasp, and use data by means of visual interactive mappings. As in software analytics, we typically handle massive data. Visualization is a key approach also for visualization for software analytics techniques.